Morning. My name is Carla Freeman, and I direct the SAIS Foreign Policy Institute, an institute founded by Paul Nitze, one of SAIS's founders, in order to provide a space at SAIS for faculty to work on research with policy experts to apply their expertise to policy challenges. It's my great honor today to open this morning's Condoleezza Rice Women Who Inspire lecture series. The series, housed here at the SAIS Foreign Policy Institute, is aimed at using the power of example to motivate students to become pioneers in their chosen occupations. Each year, the series hosts trailblazing women from a variety of career and life paths to enable students to explore different facets of leadership. Among the trailblazers who inspired and helped establish this series at SAIS in Condoleezza Rice's name is Secretary Rice's former colleague and Foreign Policy Institute Senior Fellow and our moderator for today's program, Ambassador Shirin Tahir-Kheli. Ambassador Tahir-Kheli is a political scientist who served as the first ambassador for women's empowerment under Secretary of State Rice, as well as senior advisor to the Secretary of State on UN reform. Ambassador Tahir-Kheli was sworn in as the first American Muslim ambassador in July 1990. Dr. Tahir-Kheli was a special assistant to the president and senior director for democracy, human rights, and international operations at the White House National Security Council from 2003 to 2005. Since leaving government, Ambassador Tahir-Kheli has continued to write and publish on policy and work on a number of critical initiatives, including dedicating more than a dozen years to finding areas of agreement between India and Pakistan that could change their relationship to one of productive peace. She's the author of numerous books, including a recent memoir, Before the Age of Prejudice, a Muslim woman's national security work with 3 American presidents. In 2011, she herself was named by Newsweek magazine as one of the 150 women who shake the world. And now let me introduce our trailblazing speaker and the author of the book, A Lab of One's Own, One Woman's Personal Journey Through Sexism in Science, published by Simon & Schuster in August of this year, Dr. Rita Colwell. Dr. Colwell is a distinguished university professor at the University of Maryland at College Park and also at Johns Hopkins University's Bloomberg School of Public Health. She previously served as president of the University of Maryland's Biotechnology Institute. Her research interests include global infectious diseases, water, and health. Among her many contributions is her development of an international network to address emerging infectious diseases and water issues, including safe drinking water for both the developed and developing world in collaboration with the Safe Water Network. One of Dr. Colwell's major interests is K-12 science and mathematics education, graduate science and engineering education, and the increased participation of women and minorities in science and engineering. Dr. Colwell served as the 11th director of the National Science Foundation from 1998 to 2004, the first woman to do so. In addition to this path-breaking role, Dr. Colwell has held many advisory positions in the US government, nonprofit science policy organizations, and private foundations, as well as in the international scientific research community. In addition to her 2020 book that we'll have an opportunity to discuss today, she's, of course, a nationally respected scientist and educator who has authored or co-authored another 12 or so books and more than 800 scientific publications. She also produced a film I was profoundly impacted by, the award-winning film Invisible Seas, and has served on editorial boards of numerous scientific journals. She has so many honors, I won't read them all, but do take a look at her bio online and be inspired. 2 examples, she's been awarded 62 honorary degrees from institutions of higher education, including her alma mater, Purdue University, and a geological site in Antarctica called Colwell Massif has been named in recognition of her work in the polar regions. We're so very grateful to have you join us today, Dr. Colwell. Before I switch the Zoom screen over to Ambassador Tahir-Kheli, let me just remind the audience a few housekeeping details that following Dr. Colwell's talk and perhaps some discussion with our moderator, there's going to be an opportunity for the audience to ask questions during this Q&A period. And when you're during the Q&A period, please use the Q&A function that you'll find at the bottom of the Zoom screen and then type your questions, and then Ambassador Tahir-Kheli will try to get to as many of them as possible before we wrap up the meeting at about 11:30. And if you're a student, please do identify yourself as one so that we can be sure to highlight your questions. And if you're a member of the media, we'd also appreciate your indicating that as well. So welcome everyone. I look forward to our discussion, and Ambassador Tahir-Kheli, over to you.
Thank you, Carla. This is a great morning, and good morning, Dr. Colwell. It is indeed a pleasure and an honor to have you speak to us and SAIS students in particular regarding an issue that's such an important one, women in science. So if it's an area that I think we absolutely needed to be part of the Women Who Inspire series. And so thank you very much for being here today. And if you'd care to make some remarks, that'd be wonderful. Thank you.
Thank you so very much for inviting me to make a presentation. I thought what I would do would be to speak about two experiences, my work in Bangladesh on cholera, excuse me, and then perhaps a little bit about the anthrax episode when I was director at the National Science Foundation, just as examples of the work that I've been doing. And then we can discuss the issues of overcoming barriers and the potential of inhibition of sexism in science for women particularly. First of all, let me just say that I have spent the last, oh my goodness, 40 or 50 years working on cholera and doing the work in Bangladesh. Amongst the discoveries we made was that the bacterium that causes cholera is a naturally occurring bacterium that's found in the environment, in estuaries, streams, rivers, ponds, etc. This was not particularly a popular conclusion because at that time in the 70s and 80s, it was concluded that cholera was person-to-person transmitted. But the studies have not been able to show any carriers, either animal or human. And so with our findings in the early 70s and confirmed by our work in Bangladesh in the late 70s, we were able to demonstrate quite clearly the bacterium is naturally occurring and it's associated with copepods. These are small crustacean critters that comprise the zooplankton, the plankton of the world oceans, rivers, streams, estuaries. So the work that we did on cholera, we were further able to show that we could actually predict outbreaks of cholera by using satellite sensing. The Landsat satellite that was launched in 1980 or so was able to measure chlorophyll. So we were able to use the sea surface temperature measurements of sensors and the chlorophyll as an indicator of the plankton populations, and hence a prediction of when outbreaks of cholera would occur. And we're now doing work, working closely with the British Aid Agency in England and UNICEF in predicting a month early using satellite sensing and our model that we have perfected to predict when and where the risk of cholera would be highest in Yemen. And we are now providing this as a regular service, if you will, with the British Aid Agency, UNICEF, and of course support of NASA. So that is a demonstration of the kind of work that we've been involved in other countries, India, Bangladesh, and also in countries of Latin America during the cholera outbreak some years ago. As director of the National Science Foundation, it was an extraordinary experience to be able to not only be able to do my own research, which I did, continued while I was director, but really long distance, but also to be able to fund and support all of science. from mathematics to astronomy to physics, chemistry, biology, education as well. And it was a truly extraordinary experience to be able to increase the budget of the National Science Foundation by 2/3. I wanted to double, but didn't quite succeed in doing that. But it was a tremendous experience to be able to enhance through programs in biocomplexity, to expand the computational capabilities, and to increase and double really the budget for mathematics. So while I was director, however, there was the terrible event of 9/11 and followed by the anthrax episode. It turned out that I was able to serve as chair of an interagency group that advised the CIA and the FBI on the anthrax incident, because what we did was work together as an advisory body with representatives from all of the agencies, NIH, NSF, DOD, EPA, agriculture, etc. About 13 or 14 of us would meet every Friday for an hour, and with the FBI and the CIA representatives. And we developed the capacity to determine, based on genomics, the actual source and location of the material that was used, the anthrax source that was used in the anthrax bio forensic study that we were carrying out. So for 5 years, from the original anthrax event and 5 years later, we were able to show that, in fact, the source of the anthrax was in a laboratory at Fort Detrick. Unfortunately, the perpetrator, or at least the presumed perpetrator, was not able to be apprehended because when he learned he was to be arrested, he committed suicide, which was tragic indeed. So I think these experiences of working in many other countries, of having the opportunity to lead a very important agency, provided a perspective, I think, of women in science. And from my own personal journey, a means for describing and perhaps recommending the kinds of changes that might be taken to reduce this kind of barrier for young women who are very interested in science, mathematics, and technology. Just a personal anecdote. I had, as an undergraduate at Purdue University, been accepted to medical school, and met my husband-to-be in the spring semester of my senior year. We decided to be married. Jack had spent a year doing his master's. I didn't particularly want to stay on at Purdue. I did want to go on to medical school or to graduate school. So we chose to stay, complete master's, I in biology and Jack completing his in physical chemistry. So I went to the department chairman and asked if I could have a fellowship that would allow me to stay at Purdue to do a master's while Jack completed his master's, and we would both go on to another university for our PhDs or MDs, as the case may be. The chairman said, "We don't waste fellowships on women." Now, that was a long time ago. I don't think any chairman of any department would say such a thing to a young woman student. They may perhaps say that all the fellowships are taken, unfortunately, or whatever, but I don't think they would be quite as blunt. So with these kind of comments of background of international work, work in a major agency of the US government, and some personal experiences, perhaps we can go into some discussion. And I'd be very happy to welcome any questions or to carry out any comments. if this would be a suitable approach to take. Are you muted?
Mute.
Good.
Thank you for your invaluable perspective, which is reflected in this very interesting memoir book you have, A Lab of One's Own, One Woman's Personal Journey Through Sexism in Science. You talk about both barriers and you end with some very, I think, invaluable advice to young people moving forward and wanting to be scientists, and of course, being female. So I would like to take a few minutes of your sort of discussion time here before we go to the Q&As to talk about barriers. You cite several, some of them rather hair-raising. Those of us, of course, who became professionals around the same time are familiar with some of the arguments. You know, we give the money to the man because he has a wife and children, and why would we waste it on you, or and things of the sort. I remember in my case, somebody said, well, if you are an Asian, I mean, that to somebody who didn't, she's an Asian woman and therefore cannot speak English. So, you know, it's the same kind of thing you mentioned, that one of your colleagues, where somebody said, well, we can't promote you because you just don't look like a professor of biochemistry. You know, so it was pretty blatant, but how has it changed? Because you talk about the very clubbiness of the all men's world in science, and that even as evaluators of grant proposals, etc., the pool consists mostly of men as well. So how did that stymie the effort, and has it changed at all in these intervening years?
Well, it has changed in the sense that there is an awareness, and no one, I think, would be so blunt as to say we don't waste fellowships on women. And there are many programs for encouraging women to go into science. Unfortunately, too often there are the, I don't know how to use the phrase, but the oppositionists who don't want to see programs. The claim is that to have a specific program to encourage women and girls into science is discriminatory. But it's really hard to make the argument. And I think probably the most clear way to say is that you would not go to war with half an army. You would not want to advance technologically with only half the brains. Clearly, by bringing women into the science and technology, we're utilizing all of the brains of the population, because we know that I kind of joke by saying the genes for brains, the genes for intelligence are not on the Y chromosome. In fact, there are very few genes on the Y chromosome other than for sperm production. But in any case, the point is that we need to use the intelligence of the entire population in order to advance as a civilization, and to advance as a technological society. So I think the system really has to change. It's not that we women have to change. I think it's the ability to be able to advance in our careers, in our professions, according to our ability. And that is really the challenge. It is not to make it safe or easy, but it's to make it possible that if you have a high level of intelligence capability and you can contribute, that should be welcomed regardless of sex or gender or color or whatever. So I think it's that kind of attitude that we really need to engender in society.
As you moved up the institutional ladder, did the power of your example sort of open doors to others coming behind you, other female scientists across various fields?
I think it has. In one case, simply that I've graduated about, excuse me, about 61 or 60 or so PhDs, and half of them are women. And they're doing extremely well. Four members of the National Academy have been elected to the National Academy of Science. So these have been very, very good students. They are professors, and some have started companies. And that's just one example. I'm just one woman, and there are many very accomplished women scientists, technologists, engineers, mathematicians. And I think the recognition that there is this wonderful resource that's not been tapped appropriately, that recognition, I think, is finally being understood and accepted. And I think that there is change. I thought it was magnificent that two women won the Nobel Prize this year in medicine and chemistry. So yes, change is taking place, but it's still slow. I would like to see it much faster.
Well, but we haven't seen any other female head of the National Science Foundation since you. But
Oh no, there's the second one. Yes. Franz Cordova just completed a term. She was the second to be the director of the National Science Foundation. But you are correct that there's only been one woman who has been director of the National Institutes of Health. And so it would be good to see another woman appointed, who of course is fully capable, and there are many who could be capable of being director of the NIH.
What advice would you give a young, bright female student who loves science and wants to proceed with a career as a scientist?
I would say, and you'll be amused, I would say get a posse. Get a posse, meaning make friends and gather it together in a group of like-minded young women, smart, interested in science and engineering, and meet together, have lunch, have dinner, talk over your problems, because you will find that the problems that you face, the difficulties, the obstacles, are not unique and not special just to you. They are, in fact, shared. Other women have similar, or perhaps maybe a little bit different, but you can work together to overcome these obstacles. And I think that's the most important advice.
And that brings me to something that you talk about at some length in your book, in terms of your own experience, and that is the sort of the power and the importance of mentorships.
Very, very important.
You talked about why this was so, and is it still something that young professional scientists, females, should go and cultivate or be lucky to receive, actually?
Very, very good point. And this need not necessarily be a female, because I was mentored by some remarkable men who really took, I would say, steps that were very unusual. For example, when I was a graduate student with Dr. John Liston, who remains my hero, he was a Scotsman who had come in to the University of Washington to start a marine microbiology program. I turned out to be the first formally trained marine microbiologist after going through all the travail of getting into graduate school. And when I completed my work, I'd been, my husband and I each had received fellowships from the National Research Council in Canada, and we were excited about going, but I got a second letter that said, sorry, women, husbands and wives cannot each have a fellowship because of nepotism rules. Of course, that's changed now. And so mine was retracted, but my professor, Dr. John Liston, said, well, he said that we can find a way out of that dilemma. He said, what we'll do is apply for a National Science Foundation grant, which we did. And he was kind enough to make me a co-PI. Now this is 1960. This was a long time ago when that just wasn't done. We got the grant, and he turned it over to me. And then he also talked the dean into appointing me a research assistant professor of the University of Washington, and then granting me a leave of absence so that I could go to Canada with my husband, work in the laboratory of Dr. Gibbons, who offered me the space and access to his stock room, which I could raid as I needed. And so I arrived with my own funding. I could hire a technician, and I had 2 years of postdoc work where it was all covered. That's a mentor. That's a real mentor.
For a young student today, how would she go about getting such a break?
I think that the advice in the last chapter of the book, which is a compilation of that which my co-author and I obtained from our discussions with other women scientists at MIT, at Harvard, at Stanford, at Wisconsin, at local colleges and so forth. And that is that you should be careful. You should be careful about selecting your advisor. You should, for graduate study, you should do a rotation in different labs and find a laboratory and a professor that would be able, that you could work with and you could feel comfortable with, and that you know would actually spend the time to help you develop as a scientist. And so I think rather than simply when you receive the fellowship and then just being assigned to a professor, make an effort to find one with whom you could really feel comfortable and be able to develop very fully all of your capabilities. That sounds like a challenge, but it really isn't. It's very useful to be able to find someone with whom you could be quite compatible and be able to develop very well the kinds of research ideas that you have got. So I think it takes a kind of a collaboration to be able to find just the right opportunity and environment in which to work.
Right. There's so many sort of quotes that you have, or from that I have from your book, that are very, I think, poignant. There's one that I recall where you say the system was casual, collegial, and closed.
Yes.
And it intrigued me because then you kind of stop there. How does that sort of relate to what you went through, and then fast forwarding to how it is today?
Well, the laboratory is fun to be in, if you like working in the lab, which I love. And the interactions with your professor can be very comfortable and interactive, and with your fellow students. But what you will notice, or at least during my time, and I think it still exists, is that the guys in the lab find themselves are the ones who spend time chatting out of the lab with the professor. They're the ones that if the professor is involved perhaps in translational studies, that is formation of a company or whatever, that it's the guys that he will, or the male students, with whom that he'll interact and suggest that they might want to do some work in that that new environment. It's the guys with whom I remember one particular student who called me from MIT saying, my professor goes out, gives talks, comes back and tells the guys in the lab about job opportunities and fellowships, but he doesn't tell me or my other female colleagues in the lab. What should I do? So in that case, I said, well, you probably have to go out and find this job for yourself. Anyway, she's now a professor at Harvard, so she did okay. But I think it's the fact that the collegiality gets kind of closed up for the male colleagues. And so I think this is where it's important for women to find their female colleagues, but also find those males who are collaborative and are able to assist them, tell them when there's a job opening, tell them when there's a fellowship that probably would be of great interest to them and they should apply. So that's kind of what I meant about the closed part of it. Insidious, but there.
You also talk about the, advice to be given and a focus on science for females. At what level of education is that advice best given? I mean, should in high school, even earlier, if a girl seems to be interested, should we start nurturing the talent actually in early in the schooling?
Yes, it's really critical at the grades around 5, 6, 7, but really it goes all the way back to children. The notion that little girls may not like an engineering truck or something, or that girls can't do math, that kind of attitude gets built in, I think, at ages 4, 5, 6, and 7, and then at ages 8, 9, and 10 is when we really kind of separate the girls from going into science and encourage the boys to go into science. This notion that girls can't do math is really absurd. In fact, some studies suggest, I don't know how valid they are, that girls are ready to do math earlier than boys, and that teaching calculus, for example, in junior high, girls could probably be doing calculus earlier. I have an experience with my own daughter, who I got a call from the teacher saying that he didn't think that my daughter should go into, she's now a physician, should go into calculus because she didn't, the way she was doing her work didn't imply it. Well, I got all very nervous and then hired a tutor and a young graduate student in mathematics. And after several weeks, he called and said, look, he said, I like the work. He said, and your daughter is fun to work with and the money's good, but she's doing great math. It turned out that she was doing all the math in her head and found it tedious to write the different steps. And the teacher wanted the steps all written down. So you see, the point I'm making is that girls can do math, and my daughter is not that unique.
Did you convince the teacher, or did you have to convince your daughter to change her process?
No, she pointed out that it was not, mother, why is it necessary to write those steps? It's boring. So anyway, I told the teacher what she was up to, and they worked out a system.
Because it's bridging the gap, as they say. Well, to go back to the NSF aspect of your long and illustrious career, are female scientists now sort of competitive in numbers? You talk about how as a criteria for promotions and upward mobility in academia and otherwise, that grants, invited talks, teaching, and publications comprise the sort of criteria that is used. And are women moving up in those in large enough numbers that we can now say that things are changing? Well,
they're changing, but it's sort of like moving a graveyard. It's very, very slow. The studies that have been done show that fewer women actually proportionately get grants that apply, and that women find that they have to publish more papers in journals like Science and Nature and Cell and so forth, at least in the biosciences, and similarly in the natural sciences. And so there's a sense that women have to prove themselves doubly or triply in order to advance that the average man would advance. I think the numbers still show this, but it's not as dire nor as blunt and how shall I say, crude interference with progression, but it's still slower than it should be. And you know, one of the things that I tried to emphasize in the book is that this is a tremendous cost, a cost to the country, a cost to business in actual dollars. Because if you educate women to be a doctorate in medicine or in physics or in chemistry, and they're not fully employed, and many drop out and go into other professions that don't pay as well or aren't able to make the discoveries that would bring in a new business or whatever, you can actually calculate the amount of money. And it's in the billions of dollars that are lost. And it's been shown for businesses, if you have women on the board, more than one, you actually, your profits go up. Your business does better. It's quite obvious why, because you have a whole set of perspectives from another dimension, so to speak, sort of kaleidoscopically. Instead of just having one shade and view, you've got a kaleidoscopic view and you get better ideas. I mean, this has all been shown. I'm not, hypothesizing.
It's, you know, it's something that I think, particularly in the last decade, that or even 2 decades, that we've started to focus across the board on the whole issue of not just in science, but national security and, you know, across the board. The sort of the bottom line being you do much better as a country, as a business, as a university, if you do have that full range of opinions and experiences. I want to shift for a minute from the larger science issues to where your very specific discussion in your book about your work in Bangladesh with the cholera aspects of it. And I know it's important. So I originally come from South Asia, so I understand what you were doing was really sort of cutting edge. And it particularly seems relevant in terms of your discussion of the impact of changing weather, climate change on infectious diseases. As we go through this era of COVID, your session at SAIS for the Condoleezza Rice lecture series was originally scheduled to be in person, but because of all our current situations, we're doing it virtually, and I hope we will get a chance to meet in person. So, but you know, we're living through this very strange time, and how does that relate? Can you extrapolate from your own work in the cholera and affected by weather, etc., to what we are living through in these COVID times?
Yes, in fact, this is some very exciting work that I'm currently involved in. As I had mentioned, we were able to develop satellite imagery and sensing to develop a predictive model for cholera. And that was because of the relationship of the plankton and the bacteria. And the plankton can be monitored by satellite sensing because of chlorophyll being detectable. And the non-chlorophyll bearers, zooplankton, which carry the cholera bacteria, feed on the phytoplankton, which can be measured by satellite. So you can sort of calculate mathematically when the vibrios would be released by the crashing and the breaking down of the zooplankton population, releasing the cholera bacteria into the water column. And we were able to correlate that very nicely, the satellite sensing data with the ground truth data. And so the model is very sophisticated. What we have done is to modify that for COVID. Now, COVID is a virus. I've been just, in the cholera bacterium is a bacterium. It's not a virus, but the behavior is not so dissimilar. And so in the case of COVID, the evidence is that very likely the source are bats. Bats carry a number of coronaviruses. And so the strongest evidence is that that is where the COVID-19 originally derived. So if one then studies the effect of climate on the migration and the populations of the animals and of the environment that drive the population of those animals, then you could really develop a predictive capacity, which we have done using satellite sensors, monitoring on of the U.S. On a county by county basis, being able to predict the risk of an outbreak, and it seems to fit pretty well. So we're in the process of preparing the work for publication, but this would be, I think, a very important public health tool, and that's the point I would like to make, is that using satellite sensors and the new technology of DNA sequencing and testing, let's say, wastewater, sewage waste, as we're now doing around the country, as an indicator, because COVID affected individuals shed the COVID virus in the stool. And they can shed even when they're asymptomatic, and they will shed even before they become clinically positive. So you can get an early warning by measuring the presence of the virus in wastewater, and you can get an indicator of how well your distancing and masking is working by the decline in the discharge in virus in the wastewater. So you can use the technology, that which we have learned from the pandemics of cholera, for the pandemic of COVID-19. And I think it can be very instructive. And that is actually what we are pursuing now in the work that we're doing. And so I think it's pretty exciting that we are developing, I think, in science and engineering and technology, an inclusive, now let me tell you what I mean by inclusive, including the social, behavioral, and economic sciences, along with math and physics and chemistry and biology, to understand our environment and the diversity of our environment being important for our health as humans, but health of the environment of the planet. And I think we're reaching that point with big data and machine learning and artificial intelligence to be able to understand the holistic approach to science, engineering, and technology.
Wonderful, thank you. There are lots of questions. I have many more, so I'll hold off, and let's, take some questions, please. We have a question from Edie Wilson, who is a current MA student at SAIS, asking that, do you think the same level of collaboration between scientists and our security community happens today? How do you see that collaboration evolving, which I think would be...
Yes, this is an extremely important question. Let me give a little bit of background. I wanted to point out that the anthrax investigation that I participated in, we ended up as an informal group. We worked closely, about 15 of us who met regularly every week, including the FBI and the CIA representatives. We kept no minutes. We did not formally establish ourselves as an official group, which we could have done. We could have had a presidential directive without a snap of the fingers. But then we would have had to take minutes, and we would be FOIA'd, in other words, Freedom of Information Act. So we simply met as an informal group, we called ourselves the National Coordinating, the National Genome Sciences Coordinating Committee, NSIC. No official capacity, but we worked together very effectively. So the question is the interaction and the lack of sexism, or let's say overcoming sexism, with the agencies. I do think that at the working level, that indeed the recognition of the importance of women for those agencies is understood. I hope that that it will continue with appointments to the highest level, perhaps with a new administration that will resume what I consider to be a very strong and positive acceptance of women in the intelligence agencies will resume and continue. I hope that answers the question.
There's I'll ask the follow-on question from the same student here, asking additionally, how has studying the gendered impacts of infectious disease changed?
Oh, well, I can tell you, first of all, when I was in Bangladesh in 1975, at that time, girl babies were generally not brought to the hospital. Boy babies were brought to the hospital. That has changed. And now you don't see that. And that, of course, is 35 years later, 40 years later, that has changed. And at the NIH, women were not included in various studies, just men. In fact, even estrogen studies were done in men. I mean, come on. One would think you would want to use women in such studies. And that, of course, has been mandated now by the first woman director of NIH who started that program, that policy. So that has changed.
I remember in your book also you talked about the fact that if somebody was no woman on the team, the grant can't go forward. I think this was apropos of the submarine going out for research in the Arctic.
Yes, that turned out to be an excellent experience, because when I was asked by the Admiral of the Navy what should be done about the fact that women could not go on the submarine, when in fact the leader of the science group had been chosen by her peers to be the head of the team to do the studies in the Arctic on the submarine, my reaction was, since NSF was paying for it, was, well, no women. Sorry, Admiral, there'll be no money. Of course, his face dropped a bit, and I immediately assured him and said, look, I'm not interested in a headline, because just a few years earlier, the tailhook episode of women being treated very badly at a convention of Navy pilots had hit the headlines. And so he worked it out very well, so that the woman joined the submarine in the Arctic. Her technician rowed the submarine from Hawaii, where she was stationed, as well as the submarine, as it turned out, coincidentally. So her technician rowed the submarine to the Arctic to get the equipment working and so forth. She joined it at the Arctic Ocean. But to the Navy's credit, they made it into a public relations event, because the Navy secretary and I and others were asked to join, and I spent a couple of nights on the submarine in the Arctic Ocean, which turned out to be an extraordinary experience. And the woman scientist was spectacular. She made several discoveries of a large sill that was much safer for the submarine to enter the Arctic Ocean. She discovered through the side sonar the fact that a very large, early glacier had carved out the basin of the Arctic Ocean, etc. So it turned out to be a very interesting episode, and I can say that now women are submariners, so that has changed.
Yeah, no, that was interesting because I think it pointed to something about how do you deal with this kind of a mindset and the compromise aspect of it that you try and find if you can. But clearly, on the leadership there wanted to have the project move forward, so that made that possible. Another question from Sweta Manohar saying, how do you deal with underlying microaggressions? Oftentimes, especially here in the US, the work environment has become very sophisticated in how they are discriminatory.
Indeed, I think having a good sense of humor helps, and responding with humor. There's nothing more deflating for a pompous individual than to make a gentle but humorous comment. It works very nicely as a pin in a balloon. I think, in my view, I often refer to the sexism as ranging from the criminal to the clueless. The criminal, of course, really requires law, and that, physical attack and that sort of, that is criminal. But when it comes to the clueless, it's very often remarks, for example, remarking on your clothing or whatever, you look very nice or whatever. It's unnecessary if it's inappropriate. There are times when it may be appropriate, but times when it's not. And I think then saying, well, thank you, but I did think your tie was very smart and attractive, but I didn't comment on it. I mean, without being rude, just making a point that, that wasn't really necessary, or that really was a kind of a pointless remark. And you can do this without insulting an individual, without a sharp retort, but simply a kind of reminder that, that was really kind of clueless. Thank you, but that was clueless. So I think humor, being able to recognize when it is unintentional and separating it from the intentional. And then I think, again, it's always better to find a way to compromise the situation, that is, to come to a compromise in the situation, rather than to just swallow it or to be rude in retort. I think in the middle, having some sort of humor to deal with it is probably the best.
Yeah, I really am reminded that this is some advice that I received and I pass on as well, that if you're female, and particularly if you're one of the initial females in an all men's field, which goes across science, national security, etc., you have to sort of look at it as a glass half full and have a sense of humor and know your stuff. I mean, which gives you a leg to stand on, because
Exactly.
one has to know twice as much sometimes to be able to do that. That's become almost, but hopefully that is changing across the board, but not fast enough. There's a very, I think there's an interesting follow on from Sweta Manohar, which says, also working in global health means promoting women in different spaces. I wondered if you had experience making women of different nationalities part of your posse.
Yes, indeed. In fact, I've been on the board of the Asian University for Women, which is located in Bangladesh, and it's developed for educating women to be leaders when they prefer to study in Asia rather than go to the UK or the US, especially with these COVID times. And I'm very pleased to see that the graduates of the Asian University for Women are doing extremely well. And I have worked, I think, hard to maintain accessibility for women students from India, from Bangladesh, in my laboratory. I've trained PhDs from those countries. So to me, I have found in all my travels, and I know you too will agree, that throughout the world, we're all of us, men and women, really hopeful for our children to have a future, to live in safety, and to share good health. I think the aspirations are universal, and it doesn't matter what country, what part of the world, what gender, or whatever. So I think these basic human qualities and properties need to be recognized and shared and understood. So that's really my feeling in response to the question.
Is that sort of diverse combination reflected also in your work in the United States? Is that fairly typical now, given the extensive interactions in science globally?
Indeed it is. In fact, I often get teased about my laboratory being a mini United Nations, because I've had students from Iceland and from Germany and from India, from Japan, from South America. And it's been fun, and it's been really good. I think what's been terrific is one particular program that I ran with Japan. It was a program, this was back in the late 70s, early 80s, where the Japanese counterpart applied to the JSPS program for support, and I applied to the National Science Foundation, but the two grants were coordinated, and it ran for 10 years. And it allowed for travel and exchange. And we worked on a common project where the graduate students, and I as the faculty and the Japanese faculty, would travel back and forth. One of my students worked on a Japanese research vessel for a few weeks, and one of the Japanese students worked on one of the research vessels that I was using for some of the research in the Puerto Rican Trench. And this exchange over this 10-year period resulted in proliferation of students and students of students and students of students interacting, so that we had this extended family of people who had worked together in Japan and in the US, even to the present. So that has gone on for a couple of generations of students without additional funding, but just the fact that those friendships were made and continued and extended to the students. So it just demonstrates how you can develop a program for tremendous collaboration and cooperation amongst other countries. And the other point I would make is that the kind of science being done in other countries is elegant and very, very good. Genomics is being done. I helped set up a DNA sequencing laboratory at North-South University in Dhaka, Bangladesh, and we've published a couple of papers already. The kind of sequencing that's being done is as good, if not better, than many labs in the Western countries. So I think that's another very important development.
And a question or a comment from Steve Gorzula, obviously done a fair amount of work in developing countries over 26 years, and obviously seen many examples of male chauvinism. And it says here that a couple of months ago, I gave a Zoom talk to global studies students at Bishop O'Donnell High School. The topic was my life as a field biologist. During this presentation, I showed slides of women field biologists who work with fun things such as snakes and crocodiles. But I stress that these women do not cook for men. My subtle message being that men have also need to grow up.
Good for you. Good for you. I would say, yes, you've obviously put on your big boy pants. Excellent. Excellent.
Yeah. And another question from Tanvi Natpal. Thank you for your groundbreaking work, Dr. Colwell. I would love to know how you think scientists should engage with governments and policymakers who may want to see economic benefit or loss numbers as key to decision making. Science evolves and learns, as we have seen during COVID, and policymakers can't seem to understand that this at all. Aside those who also deny evidence, we'll leave that aside for the moment.
Okay. Well, this is really a very good and fundamental question. In fact, let me use the following to answer essentially that which I'm trying to make, point that I'm trying to make. There has been some report of the potential of adding $2 billion to the NSF budget, but with the requirement that a new technology department or component be formed and the money be mostly there. That's a mistake because the technology derives from the fundamental science. And it's really critical that the basic research for the National Science Foundation be funded. Because, for example, let's just take laser surgery. Some 20 or 30 years ago, a physicist was wandering around the lab and doing very innovative, creative studies for which he won the Nobel Prize on lasers. But for the application of lasers came some 20 years later. In fact, one of the applications was quite by accident. One of the graduate students was aligning up the laser beam and it accidentally struck his eye. He was rushed to the hospital and the physician attending was fascinated. He said, "That's a perfectly round hole." He said, "That is amazing." Anyway, the result of that interaction with the student was fine. The interaction was that that kind of surgical application developed from the use of, from the discovery of lasers and laser technology. So to answer the question, the end point requires a starting point, and the starting point is creativity and creativity-driven science. The technology, the engineering is hand in hand, but you have to understand that to get from here to there requires the investment in the fundamental science. And I think the question about should women be involved in the policy making, absolutely. I think just as women may be involved in cooking, women can be involved in cooking good policy. And I think women certainly provide a dimension and a path of thought that's very, very important.
Which brings one to the whole issue of funding for science in the United States. Long been a bastion of very fundamental, cutting edge research. Is that being affected as other commitments to research, et cetera, are declining? In the US is the budgets of the National Science Foundation, which then oversees so much of the work in sort of fundamental science around this country?
Well, I think the budget for the NIH has certainly expanded. I think it's close to 38 billion, 36 anyway. The NSF, I think, is now around 7 billion. It really, you can see the disproportionality between the funding for NSF and that for the NIH. I kind of humorously ascribe it to the fact that nobody ever died of physics or mathematics. So you don't have a poster child. But seriously, I think it's critical that the fundamental sciences and certainly mathematics, which is really the Esperanto of science, technology, and engineering, these basic sciences, but also the fundamentals of social, behavioral, and economic sciences, because understanding how we function in a complex society really needs to be understood. And with big data, we are able to derive the fundamental patterns that can explain and can provide new ways of doing things that can be more effective and more productive. So I think the richness of the funding of the National Science Foundation is such that it really does merit. Even John McCain and Newt Gingrich had said to me years ago when I was director that the NSF budget should be tripled. Well, I think it certainly should be tripled now, even when the budget is $7 billion. I think 20 billion is probably a good number for the National Science Foundation.
Is there support in Congress for something like that? And currently, it was an interesting discussion you had with, Gingrich when he was speaker and an important person in Congress. But is there a feeling, given the sensitivities currently about movement of cutting edge science to China using sometimes or often the intellectual property created here, but is there a feeling that in order to beat China at its game, one needs to actually triple NSF and other budgets?
Well, that's certainly one rationale, but another is simply to compete in the business dimension. To create new businesses, you need the technology and the science and the creativity and the ideas. And so innovation is underpinned by the fundamental science that's done. So I think, well, surprisingly, the $2 billion that I did hear about and read about did come from Congress. So there is an understanding that investment is needed. But what I was trying to point out was that you don't invest in the end game. You have to invest in the beginning, the fundamental science that leads to the end game, which is the technological applications and so forth.
You use this phrase, I think, in the context of both funding and in the advice to young scientists to follow the science. To follow the science, you said.
Yes.
What precisely do you mean by that? Because it intrigued me. It seems like I'm married to a physicist and the daughter of one, so I've heard this, but maybe.
Because I think the creativity and the innovation that comes from scientific exploration, whether it's thinking about going to the moon again, or going to Mars, or whether it's trying to understand what the receptor site for the COVID virus is, and how is that receptor site distributed throughout the organs of the human body, hence the susceptibility of the lungs and the liver and the kidney and so forth, and the heart, and even the brain to be susceptible to this virus. That comes from questioning, from understanding, and from asking and seeking answers. So you follow the science and you learn how to save yourself and protect yourself in this very complicated world that we live in.
And I think you also talked about the importance of sort of STEM work and getting young adults interested who have a proclivity towards it but may not pursue it because nobody really encourages it in their early education. Is there a way of, I know there's no magic formula for switching on this kind of a spark, but is there a way we could, given that people are thinking actively at present about how to redo education for young adults, and is there a way of doing it that you would advise?
I think that we should, again, return to what I remember as there were different levels of science courses. There were the courses in science for those who wanted to become lawyers, who wanted to become, let's say, business people. It's important to know something about science, no matter what your profession that you choose. And particularly, obviously, if you're interested in medicine and science, that you want to learn the fundamental principles of physics and chemistry and mathematics. But I think it's useful for those who want to go on to business, those who want to be involved in even literature and history and philosophy, to understand the basic tenets, the basic principles of how things work, without having to become the expert electrician or plumber, but to have an understanding, I think, of how the world works is a good thing. It's part of a well-balanced study, which I would say, on the other side, it's a good idea and a good career development to study literature for a scientist, not a bad idea to read a bit of poetry and to appreciate art and music, because that can be very creativity stirring and elevating. So I think it's trying to achieve a balanced life where you can not become necessarily a wonderful pianist or a cellist, but to appreciate music while you at the same time are an excellent physicist, and vice versa.
At the sort of practical level, as you advise young women to chart a scientific path for themselves, you mentioned that you would recommend that women do 2 extra years of postgraduate work if they expect to earn as much as male colleagues do. Why? How?
Yes. It's part of the system that we have to achieve more, but it's also important because it allows you then to be prepared to become the leader and not necessarily only the follower or the technical individual, but to be able to head the lab. And I think the additional graduate work gives you the competence and the confidence to be able to take on the challenges. And I think that then gives you a kind of a leg up in this not quite equal world we're still living in.
So it gives them, it's not just that the extra knowledge they acquire, obviously, if they're doing more work, but just being a graduate student exposes one to a different range of experiences that becomes relevant in the company.
Absolutely, yeah. It is both relevant and it's confidence building as well. Knowing and experiencing that in fact you are as good as the others in the lab. I don't know how, I guess I can say that I can at least recount 4 women students who came to my lab and said they only wanted to do a master's degree because they weren't good enough. They didn't think they were good enough to do a PhD. And my reaction was, good Lord, let's see what you can do. And I was convinced that they certainly should do their PhD. They did get their PhDs, all 4 of them. But there's this tendency of women to suffer the imposter syndrome much more than men. Men sometimes do, but to feel that they're not as good, and that when they do earn a PhD, that maybe they really didn't deserve it. Well, they certainly did, and they certainly did the work. So it's the confidence, again, the point that I was making. It gives you the information, but it also gives you the confidence.
Does it also provide better opportunities for that mentorship, acquiring a mentor and then, having a network of female scientists, the exposure is at a different level. So I imagine it's much more comprehensively useful, if possible to do. But
It is indeed, yeah.
Well, in the few remaining minutes, I wouldn't call this just exactly just a fun question, but I wondered if you would reflect on your working with NASA. There are not that many people bridging the divide between actual being a scientist and going out there and using the facilities and everything else that NASA provides. What was that like, and what did it add to your experience and to your research?
Well, it's been, I have to say, totally positive. The initial studies back in 1990 and to 2000, that first paper was on the use of satellite sensing, was with the team, Brad Lobitz and the team out at NASA Ames. They were wonderful because we worked together collaboratively, and I can remember so vividly being at the NASA Ames with the group, and as we did our analysis and the results came out of that correlation of the sea surface temperature in the Bay of Bengal and the correlation with the numbers of cholera cases, we kind of did a little dance in the lab because it worked out just so well. And then subsequently, I continued to be funded by NASA, and the current team are just superb. This is at the NASA, the local group in Maryland. They are absolutely the best to work with, and there are seminars every couple of weeks that I attend. Now, of course, it's virtual rather than in person, but I cannot say more strongly positively the fun that it's been to work with the team at NASA and with their own interest, and I think the excitement that what they're doing can also be used for public health and for medicine. The applications are very clear now. There are many applications, everything from climate change, extreme weather events, obviously being able to predict major changes that are due to the cycle of the sun, etc. So it's been fun. It's been rewarding. Lots of good papers, 15 or so papers now, maybe 20, and tremendous colleagues. So I'm glad you asked, because that's
I noticed that you talked about it also in terms of Yemen and so on, and it's a whole other very critical arm that one can use. Do you find that within your sort of NASA colleague experience that there's obviously a prevalence of males, I assume, but it's okay to be a female scientist, and that's not an issue? I mean, you have taken them into space, so I assume by now that's
not an issue. Franz Cordova, whom I mentioned was the second NSF director, had served as chief scientist for NASA.
Great.
She's an astrophysicist. I think that the work in Yemen has been particularly rewarding, and we're now expanding it to Africa. We're now using that. Mozambique and the countries along the western coast of Africa have been suffering some severe cholera outbreaks, as has the Republic of Congo. So we're planning to do some ground truth measurements, that is, studies of cholera isolation from water sources, but also continuing the NASA satellite studies and expanding to Africa.
Well, that's exciting. Well, I think, Dr. Colwell, I could go on, but we're reaching the end of our time. I want to thank you for being an inspirational woman for the Condoleezza Rice Women Who Inspire lecture series at Johns Hopkins School of Advanced International Studies. So on behalf of all of us at SAIS, I want to thank you for this time you've taken. I want to thank you for the work you've done and the work you do and the path you've blazed and for this very interesting book that I just absolutely enjoyed reading and learned so much from. So thank you very much, and look forward to meeting you in person, hopefully soon.
Thank you, Ambassador. It's been an honor and a pleasure to speak with you and to be on this very interesting program with you. And I thank you and Carla and all of the team at SAIS for this opportunity. And I really have enjoyed it very much and look forward to continued collaboration with my colleagues. Ambassador, thank you so much.
Thank you, and thank you to our excellent team that had the three of us in 3 different locations, and some of us less tech savvy than others, and we managed to do this. So thank you, and thank you to the audience for being part of this.
Indeed.